Hello, I'm Dr. Lawrence W. Moore. I'm here with my assistant Crafty. Let's get him in frame. Yeah, there he is. And this is Sunday Night Synthesis. And tonight we're going to be dealing with the topic wavetable synthesis, especially using phase at the audio rate. Those of you who have been working with pure data probably know that the standard oscillator and phasor objects do receive phase values, but they don't receive them at the audio rate. So how do you get smooth transition of phase without hearing all those artifacts, the sputtering sounds you hear? Well, tonight you'll see how to do that. Also, you'll probably see and get some ideas of how you can use wavetable synthesis to create, phase sounds and create some pretty cool effects. So, in other news, I am working on more modules for LWM Rack, and I am working on that video that describes how the modules work from the inside that will be coming up in Learning Synthesis with Pure Data, Series 2, Episode 5. I should have that out this week, and then the new modules for LWM Rack will be coming out soon after that, maybe even this upcoming weekend. But anyway, it's a busy time. It's a busy time of the year, getting ready for the fall semester to start. And I'm also in the middle of a quarter here where it's midterm time, so I have to get some grades in tonight. Okay, so anyway, that's my problems. Let's check this video out, and I'll see you in a few doing what we do. Okay, I'm here at my website, lwmmusic.com. Just wanted to show you about what's coming up. As you see, LWM Rack is currently the latest post, but just so you know where it's at, if we go to the software page, there's LWM Rack. But what I said in the opening is that to see how these things are built, that's all going to be in the Learning Synthesis with Pure Data series, which is under the Learning page. And it's Series 2. These new episodes that are going to deal with the construction of the new LWM Rack are going to pick up where the old LWM Rack episodes left off. So it'll be Lesson 5 where that begins. Depending on when you see this video, it may be, already well going. I plan on putting out that Lesson 5 episode this week. This is the older, more bulkier version of LWM Rack, but you can check those out too. There's still a lot of good programming that went into that, and very useful stuff there that might give you ideas on your own builds. Okay, so we're going back to Sunday Night Synthesis here, and so I am going to minimize my web browser and open up this patch. Okay, let's zoom in on it. Here we go. Okay, so this is about wave shaping, basically using wavetables to create signals, and then a way of getting around one little limitation in Pure Data when you do signal generation in a different way. For example, if I were to just make an oscillator object here, we'll just say 440, and then let's hook this up to a DAC. Yay! Okay. Turn this off temporarily. Now, you probably already know the information, well, floating point numbers that are sent in through the left inlet will give you frequency. I gave it the creation argument of 440, so it's already doing a 440 Hertz tone. And the right inlet is where you give phase. And these are in ranges of 0 to 1. So like a 360-degree phase cycle is 1, 0 to 1. So you have to decimalize it. If you want 180 degrees, that's 0.5, halfway through. 90 degrees, 0.25, a quarter of the way through, and so forth. But the thing is, I'm going to do this differently, actually. I can just duplicate this one. This is a slider that's going from 0 to 1. So that way we can get a bunch of values in between. Okay, and now I'm going to turn DSP on. You'll hear as I move phase here, a lot of sputtering that takes place. Those are artifacts. Let me turn DSP off. So those artifacts are created because you're changing the shape of the waveform, and it's kind of jumping to do so. It's not changing the shape in a smooth way. In order to get it to change shape in a smooth way, these numbers should be sent using a mechanism like this. A pack message that packs up the number that's sent into it, which would be your phase number. Number of milliseconds, I like to use 50 milliseconds. Through line tilde, we'll basically go from number to number to number over 50 milliseconds, smoothing out the values in between into line segments. And this gets rid of artifacts, those sputtering sounds. Now, the thing is, the typical phase inlet on an oscillator object as well as a phasor object, which are common ways of generating waveforms, does not accept things at the audio rate. For example, if I try to hook this line tilde up to it, it doesn't hook up to it. It doesn't accept things at the audio rate. So, generating signal this way doesn't allow you to change phase in a way that is smooth. Sorry, this is bugging me. I want to make that smaller. There we go. So this is a demonstration of a way around that in order to get smooth phase changes. What I have here is a load bang that executes these functions when the patch opens. I put a little bang next to it in case I want to execute these while the patch is open for some reason. Mostly I was using that during the debugging process. First thing it does, the rightmost bang here in this trigger bang bang bang, turns on DSP. PD DSP1 is the message for that. Then it goes here to the sample rate object where it bangs out what the current sample rate is. 44,100 is the default. And then that gets sent out as a send here under the name $0-sample rate. The $0 is just a unique identifier for this patch. Anything loaded from file, a $0 gets replaced internally in PD's thinking with a number, a unique number for that file. So this way, this kind of patch can be loaded as a sub-patch into something else, as long as it's loaded from its file. So, but that's sent out because I need the sample rate to come through somewhere else. And then a trigger bang float. The float carries the number through, and what it does is it goes down to this pack message here, which I'm coming to in a second. And then the bang here bangs this symbol, $0-waveform. If you've seen last week's episode, this is because I found if you want to use a name with a $0 in it for a table, and it's going into a message box, you need to send it as a symbol. Otherwise, it drops the $, and it just calls it 0-waveform. In other words, it won't find it. So this is just a workaround, so that works. And that goes into the pack message here, the symbol, and then the number of the sampling rate. And it gets sent to this message. So the first part of the pack message is represented by the $1 variable here. That puts the symbol $0-waveform, resize, and then $2 is the second part of the pack message, which is the sampling rate. So it resizes this table to be the size of the sampling rate. So sampling rate is samples per second, so this is 1 second of audio at the sampling rate. And it's the size, this table, is 44,100 points wide. They don't all get displayed here because you just kind of see a shrunken version of it, because I don't have 44,100 horizontal resolution to the monitor, and so it would be actually really big. But it has all those points in between, and that's all in memory. So PD knows all those numbers in memory. It just gets displayed smaller. So anyway, the next thing that happens here, the third and last bang that goes through, is banging this oscillator here. And it's banging through a frequency 1. Its default creation argument is 1 also. I guess I don't really need both of these, but I just put them both in anyway. And then I give it a phase value of 0.75. The reason why I did that is you'll see right here, if I put 0 in for a 0 phase, the oscillator tilde object is actually right. And so in order to make it fine shape, let's make it 0.75, a sine wave shape. There we go. So this gets generated as the patch opens. And so that's all this is. This tab right writes it to table. Basically, the oscillator gets its phase, its frequency of 1 cycle per second, so we get a single cycle of the waveform, and then tab right gets banged here, which tells it to actually write. Okay? So this is now the waveform that we're going to use to create a sine wave. And the way I do that is by using phasor. Right down here is where this mechanism starts. Phasor's output goes into here, a multiplier, star tilde, because it's at the audio rate. And this receives the sampling rate in. So at this point it's 44,100. So this basically multiplies the output of phasor by 44,100. So phasor normally just goes from 0 to 1, 0 to 1, 0 to 1 at the audio rate, and with the frequency that you give it. If you give it frequency 1, it goes 0 to 1 over 1 second. Now by multiplying it by the sampling rate, in this case it's going to 0 to 44,100. If it was at the frequency 1, it would be doing it over 1 second's worth of time. Because the default state of horizontal sliders and number boxes are to be zeroed out, it's a 0 right now, so we don't hear anything, even though DSP is on. Okay, and then that goes into tab read here. So it reads this table. Phasor is pushing it going 0 to 44,100, 0 to 44,100. So it's shooting out sine wave shapes at the frequency that you give it. Alright? Now, this is where the phasing comes in. We also have phasor going over here to where it's being added to this. At this point, phasor is still going 0 to 1. This is before the multiplier down here. And so we add it to what comes through here. This is range 0 to 1 also. This is where we create our phase. For example, if we put this in the middle at 0.5, then whatever values are coming through here get 0.5 added to them. So it would really be going from 0.5 up to 1.5, the phasor's output. But then it goes through a wrap tilde object set with the creation argument of 1. So what this does is this wraps things around that go above 1. So it goes from 0.5 up to 1, and then back around from 0 to 0.5 again. Then it gets multiplied by 44,100 before it goes to tab read. So what is essentially happening is the left oscillator section is starting here, going 0 to 44,100. This one, since I have it set to 0.5 right now, is starting here halfway through, going through here, wrapping around, and going back to here. And it's doing that at the same frequency because it's coming from the same phaser. So we now have two different signals being generated. One of them is out of phase with the other and is set at the phase that we set here, which tells this adder, this plus tilde because it operates at the audio rate, what to add to it. And because it gets wrapped around, it stays between that range of 0 to 1. Now, if I turn up the frequency here, the reason why we're not hearing sound is because my phase is at 0.5. This signal chain and this signal chain are canceling each other out, because one on the left is starting here, going up, down, like that. The other one's starting here. So while this one's going up, this one's going down. And on a normalized table like this, this is a range of values going 0 to 1. This is a range of variables going from 0 down to -1. So this is the negative copy of these. And so they're the same numbers added together, except these are negative numbers, so they cancel each other out and flatline. And so, if I move this over, we hear the sine come back in. Because at this point they're adding to one another. Now down here, basically both signals are being added together, and that's how we get phasing. And then I multiply it by 0.5 just to make sure that, when these are exactly lined up in phase, we'd be distorting, we'd be going outside of normalized range because the two waveforms would be adding together. And so they'd be going really from 0 up to 2 and down to -2. And so this is how you protect yourself, is by attenuating them. Now with a sine tone, phasing doesn't sound very interesting, but we could do this with other tones. To do this, though, I'm going to turn DSP off temporarily and show you how we can do it. I'm going to save this file to a different file name real quick, because now we're going to make a sawtooth wave that does the same thing. Okay, so this is where we need to do it. We need to change the shape in here. This is what creates the sine wave shape, so we want to change this. So I'm going to delete both of these things here. And to make a sawtooth shape, we start with a phaser. And once again, I guess I'm going to be redundant, but I'm going to include the 1 as a message. It's been working, so if it ain't broke, don't fix it. And also, I like for the frequency and the phase to be sent to the thing right about the same time. Technically, the phase gets there a little bit before the frequency. But we'll see what this shape creates. And really what it's going to create is the shape of phaser itself. This is going to turn it on, but I'll turn DSP off right away. Oi! Heard it temporarily there. Oh, I don't have it hooked up. Needs to be hooked up to tab right to write its output to table. See, phaser goes from 0 to 1. And so it's doing that here at 1 cycle per second. So over 44,100 samples per second, it goes from 0 up to 1. This is almost a sawtooth, but not quite. Sawtooth really goes from up here down to here. 1 down to -1. This actually sounds quieter than a sawtooth would. So we can make it a sawtooth by doing a little bit of math here. First of all, let's make it thicker. Well, let's get it going the right direction first. Star tilde -1. What I'm doing by doing this is we're going to get it to go from here down to here. Then we're getting it slanting the right direction at least. Hook it up and you can see. Alright. Now we need it to be wider. So the way we do that, it really just needs to be double the size that it is. So we multiply it by 2. Going from 0 down to -2 because we're multiplying it by -1 and then multiplying it by 2. Well, we can fix that. We need to get it to go from +1 down to -1. So we can do that by simply adding 1 to it. And then we'll have the proper sawtooth shape. Okay, now let's do a little phase. Turn this off. So now, you hear, we have phasing. I'm going to save it at this point, but I want to show you something. For example, now that this is at the audio rate, that we can feed things into the plus tilde. We could even hook up, for example, an oscillator. I'm going to make it a phaser because the actual phase values are 0 to 1. Let's make this phaser go at like 4 cycles per second. So we'll hear it go throughout the phase of the waveform 4 times per second. All I have to do is turn it on. There we go. So now in other patchings you could feed in signal from an LFO, for example, or have your mod wheel or something control phase, as long as you send it through this line tilde with a pack message of the number of the phase plus here something. It's got to be above 20 milliseconds at least, and then you'll get a smooth transition. But yeah, if you send in numbers without this line smoothing it out, you're not going to get, you're going to get artifacts, in other words. It's not going to be a smooth transition because things are not being sent at the audio rate and they're not being smoothed out as they transition from value to value. So anyway, there you go. That's a way of changing phase and not having artifacts. Changing phase at the audio rate. And there we go. So I'll see you next week for more Sunday night synthesis. And keep an eye out for the next Learning Synthesis with Pure Data, Series 2, Episode 5, where I'll go into the making of these basic set of modules for LWM rack. And then right after that, I have already begun making more modules, so they'll be released in groups according to type, and there'll be plenty of building to do. So I'll see you around.